melihat terlebih dahulu tayangan berikut ini.
I've been at the University of Rochester Medical Center for approximately 21 years. I'm actually born at this hospital. I love what I do. I love facilities. I love engineering. I am Mark Schwartz. I'm the Director of Facility Operations. We see approximately 140,000 inpatients per year and over 1 million outpatients. Given the scale of the medical center and the age and the different components, we have a tremendous job trying to keep it all operating on tight budgets. To provide medicine to the highest order, we need buildings that perform to the highest order. Asset performance service has allowed us to identify which equipment we need to upgrade, retrofit, or replace prior to actual failure. It is really about taking building equipment and giving it life, giving it intelligence. When there's an alert, we get a notice, and very often we'll get a call from the Schneider Electric Service Center, and to understand that we have somebody else on the team makes us all sleep better at night. Asset Performance Services is really the beginning for us to build on the Schneider Electric EcoStruxure platform. Reliability, especially on large, older infrastructure like we have here, is paramount. In 2 incidents alone, we have saved several hundred thousands of dollars.
Ladies and gentlemen, please welcome on the stage as moderator for Efficient Building for Cooler Planet, the Vice President for Eco Building East Asia and Japan, Rest of the World Operations, Schneider Electric. Welcome on the stage, Mr. Jean-Baptiste Hazard.
Good afternoon to all of you. Thank you very much for giving me the privilege to be the last presenter this afternoon, but for really the most important topic, because we are going to talk about green buildings. And green buildings, this is where we live, this is where we work, and this is where we have fun. So it's a very important topic for this afternoon. So I'm going to start by a presentation about some megatrends that we observe with regards to green buildings, and then we will have a panel discussion with all the panelists that we have today. So, on the presentation, first of all, I would like to start with one of the big trends, which is the urbanization that we have in our planet. In the next 35 years, there's going to be 2.5 billion more people living in the cities. Okay, it's a big number. What does it represent? It means that we're going to build the city of Jakarta 7 times every year for the next 35 years. The cities are going to become bigger, and there are going to be more and more cities. And what is in the cities? Buildings are in the cities. The buildings consume 53% of the world electricity. And given the urbanization that we have, this consumption is going to increase by 80% in the next 25 years. Therefore, it's very important that we make these buildings greener and more efficient. When we look at the way the buildings are designed, today they have multiple silo systems. What it means in terms of silo systems, it means that it's multiple networks from multiple vendors, many systems to troubleshoot, many systems to learn, and a challenge for the operations. It's a much higher capital and operational expenditures. And finally, they don't help us to achieve energy efficiency. Now, when we look at the huge untapped potential that we have in the buildings, the number one potential is with safety. You know, I'm French. Nobody is perfect. Sorry for that. But I took some statistics. And one of the statistics is coming from France, which is amazing. Can you imagine that in year 2015, we had 600,000 electrical accidents? In the US, there were 50,000 home fires due to electrical failures. So we believe safety is a given, but actually, even in some of the most advanced countries, safety is not there, is not a given yet. So safety remains a very big untapped potential for the buildings. The number two is the energy efficiency. It's interesting when we look at the potential for energy efficiency. You know, in the industrial world, there is still about 58% untapped efficiency. Because, you know, in industry, there have been a lot of productivity, savings. It's a normal kind of trend happening for many, many years. But when we look at the buildings, they represent about 80% untapped energy efficiency. And we believe that we can gain about 30 to 50% easily on the buildings. When we look at the operational efficiency, what is interesting is to look at a building across its entire lifetime. The actual construction and initial investment in a building only represents about 25% of the cost of a building across its entire lifetime. 75% of the costs are occurring after the building is constructed, and 75% are going to maintenance and operations. And therefore, very important to have the most efficient operations and to have the most efficient systems allowing to reach the most efficient operations. And here in the maintenance, what is interesting is to look at preventive or predictive maintenance. Predictive maintenance is giving 10 times more return on investment compared to just reactive maintenance. So it's good to have systems analytics allowing us to optimize maintenance in the building. Last part of my presentation is really to look at some of the big technologies and some of the big trends that we are facing on the market today. First one, we talk a lot about it. We see it a lot everywhere where we are, is the Internet of Things. The number of connected devices is going to be multiplied by at least 3 in the buildings in the next 5 years. At home, it's going to be even worse. It's going to be multiplied by 13 in the next 5 years. And I believe the reality is going to be much more than that. Because we see around us, everything is becoming connected much faster than what we can expect. Second big disruptive technology is actually about the solar and the storage. The costs of these technologies are reducing drastically. About today, the solar capacity in the world is less than 20% of the total electrical capacity that we have in the world. It is forecasted to reach about half of the world capacity in the next 25 years. That's going to change a lot the way we produce electricity and the way also we want to design our buildings. Last one, you know, I talked about maintenance, operations, lifetime of the building. Is, you know, a technology which is the building information modeling, BIM. Some statistics are showing that about 5 years ago, 40% roughly of architects were using the building information modeling on their major projects. Now, it's about 80% of the architects which are using this technology on their major projects. And it allows to simulate the behavior of the building, from the design, the construction, and its operations. And it allows to really look at the total lifetime and the total life cycle time of the building and how much this is going to cost and how we can optimize all of that across the years. So to summarize what I just presented, the buildings of tomorrow, they have to be connected. They have to be sustainable. They have to be efficient. They have to be reliable. And the most important, they have to be safe. So a question that we can have, okay, how can we make it happen? Do we have solutions today to allow to make buildings like that and to meet these expectations? Schneider Electric has some IBMS architectures that allow to make this happen. We call it smart structure. We also call it eco-structure building. Don't worry about the name, something structure. This is the architecture that allows to make it happen. With smart structure, we can actually combine the electrical part, the mechanical part of the building seamlessly. We can manage the HVAC, we can manage the lighting, we can manage the access control, we can manage the structure cabling, we can manage the power and the power management facility in the building. All of that through one integration platform that we call smart structure. We have exactly the same kind of architecture, which is more focused on power. We call it power structure. And to summarize all of that, this overall global architecture that we have is eco-structure. The way eco-structure is designed is that it starts at the bottom with connected products, connected devices. This is what I talked about, in the mega trends about connectivity. There's going to be more and more connected devices. That's where it starts. So you have valves, you have sensors, all these kind of devices, even field controllers, they are connected and connectable. Then the second layer is where we put what we call edge control. It's a software layer, which is in the facility where we are, and that allows to control all these different products and devices. And it creates actually this seamless integration between the mechanical, the electrical part of the building. And finally, we put another layer on top of that, which is analytics. We basically take the data coming from the building, we send it to the cloud, and we have our experts that analyze this data and send back preventive, predictive, maintenance advices to the people operating the buildings. And it allows to reach the best efficiency in the buildings. So I'm done with this presentation, this introduction about the green buildings. So let's have a video first, which is a video with regards to the Edge building. It's a building that we have made in the Netherlands recently, which is the actual showcase of putting together all these systems to reach the most efficiency in the building.
It is called the edge because we're on the edge of technology. When the board asked me to construct this building, I made sure it has everything like Internet of Things, sensors, sustainability, and integrated those into a data analysis platform. My name is Eric Ubels. I've been the CIO for Deloitte for 23 years. Within Deloitte, I'm in charge for facilities and real estate, but I have a huge passion for technology. The smart structure of Schneider Electric is basically the whole backbone of this building. The building is obviously the most sustainable office building in the world. The way the architect designed it, using the natural part of the sun and sunlight and solar panels, it produces about 102% of the building's energy. The most important thing for a smart structure from Schneider is the single backbone, so we would be able to connect everything. but also to get the data into a data analysis platform. And you can learn, and therefore you can make smarter algorithms, even lowering the energy further. But it's not just sustainable, but it's also extremely comfortable to be the best workplace for our people. Schneider Electric being a single integrator, for us, it worked extremely well.
So for the panel, I want to call first Rana Nasir. Rana is the retired director of Rating and Technology Green Building Council in Indonesia. He's also the past president of ASHRAE Indonesia, Chapter 2009, and he's the deputy chairman of Indonesia Society for EEC. Welcome.
Yes, nice to see you.
Rana. Rana deserves a big round of applause. He's coming from Bali just for this event, so please. Now I call Sugwon Tono Tonto. Sugwon is the Retail and Operation Director of Ciputra Group. He has 27 years of experience in developing and operating commercial buildings. Welcome. Agus is the Managing Director of PTSD Swasatya. He has over 35 years of experience in M&E services, design, engineering, and project management, and he's a co-founder of the Green Building Council Indonesia. Welcome.
Thank you.
Agus. And finally, Edgar Alcazar. Edgar currently serves as the technical advisor for Sinarmas Land. He previously served as the Vice President and Technical Director for Ayala Land Property Management and Engineering. Welcome, Edgar. So for the panel, we're going to talk, of course, about the efficient and green building. And I would like to start with the first question for Agus. The first question is about how you define an efficient, cool building.
Okay, thank you. My name is Agus from PTSD. Well, good afternoon. The question is it's not difficult to answer, but it is very difficult to be implemented. Do you agree that?
Fully agree. And it's aligned with what we discussed.
Well, to achieve efficient building, a lot of process starting from the design, construction, testing and commissioning, and also the operation and maintenance has to be properly done. Yeah. Otherwise, if one phase is failed, then the result is not there. You know. As a consultant, I emphasize on the design process. Other maybe from the green building. Yeah. As you know, that the AC system is consumed about 50 to 60% of the building consume energy in the building. Yeah. There are several factors that are interrelated. First, is actually interconnection between passive design and active design. Passive design means that actually for the building orientation, facade design, and material selection. Yeah. This also will affect in our sizing of the AC and also the system of the AC. If you have so many cooling load external from them, the energy also quite a lot. Yeah. The other aspect is also the equipment of the assay. It means that actually each equipment they has their own metric that define how efficient the energy it is. For example, the chiller, how many kW per ton. This is also important because if we select the chiller, small power, it's quite difficult to get the energy efficient. And also the other factor is providing the complete system of the control, automation, and also the testing and commissioning facility. Otherwise, if you don't have any facility, for example, water and air balancing, then it's quite difficult also to get the efficient of building because it may be some of the energy will be not wasting. Yeah, it's wasting. The other aspect is on the efficiency of building is also the user interface or integration sometimes. Yeah, integration means that actually if we can utilize the advanced technology of the digitalized, then you can have a fast response and also fast action in this case. So I believe this one also will create some additional efficient on the energy. Yeah, I think that one is.
Okay. Thank you. Thank you very much, Agus. Next question is for Rana. It is about the policy and strategy that we have for the new and existing buildings and that green building has or plans to have for Indonesia.
Okay. Thank you, GB. But please allow me to still sit here because we are on a panel discussion, not on a presentation, one thing. And then please allow me to speak in Bahasa because I think it is much more for us to, more closer on the feeling. You're asking about the policy and strategy? Then we start, I will start with, okay, in Bahasa, sorry. Okay. Kalau kita bicara strategi, maka kita harus bicara sebetulnya mengenai mission. Apa mission? What is the mission of the Green Building Councils? Misinya adalah mentransforming the building industry to want to implement untuk melaksanakan green building concept, green movement. Waktu dibangun Green Building Council, di mana saya, Pak Agus, kami berdua adalah founder dari Green Building Councils. Saya diberi tugas untuk menyusun rating tools, karena itu saya sebagai Direktur Rating Technology pada saat itu. Nah, rating tools adalah suatu alat yang akan dipakai untuk mengakses sebuah bangunan, apakah bangunan itu bisa disertifikasi sebagai green building atau tidak. Nah, alat assessment itu rating tools terdiri dari kriteria dan benchmarking. Kami butuh hampir 2 tahun dalam menyusun itu. Nggak mudah karena at that time nobody knows, nobody understand about that, about the green building. Even I can say at that time we don't know what we don't know. Oke. Nah, kemudian kalau kita memenuhi kriteria dan mencapai benchmark, we get the point, ada available point. Jadi kita memutuskan kemudian setelah ada konsensus bahwa poin yang terbesar adalah di energi. It proved bahwa energi adalah the most important thing on the green building. Itu nomor 1. Kemudian apa strateginya? Benchmark yang kita tetapkan dalam rating tools untuk setiap kriteria, kita tidak membuat benchmark yang high level, artinya yang very efficient. So what we put as a benchmark at that time is affordable level yang bisa diusahakan oleh most of the market players. So jadi mereka mempunyai interest to join the green movement. So that is the strategy. Not too high, but of course not too low. Otherwise we cannot call the building as a green. Tapi not too high. And then afterwards, we improve the benchmark by updating the version of the rating tools. For instance, on the new building, we're starting with version 1.0. Right now we have already 1.2. And on a very short time, we'll issue or launch the version 2.0. Sebagai contoh, apa improvementnya? OTTV misalnya, tadi Pak Agus menyebut mengenai passive design, OTTV, overall thermal transfer value. Waktu mulai kita tetapkan sebagai baseline OTTV dengan nilai 45 watt per meter persegi. Tapi pada versi 1.2 kita tetapkan OTTV sebagai baseline adalah 35 watt per meter persegi. That's already increased, higher level. Lighting power density, originally we take about 15 watt per square meters. Yang terbaru sudah 12 watt per square meters. Jadi itulah cara kita untuk membuat sebuah improvement dalam strategi bagi new building. Bagi existing building itu juga improvement. Sebentar lagi akan keluar versi 1.1 di mana salah satu kriteria adalah energy efficiency index untuk office. Sekarang masih ditetapkan 250 kWh per meter persegi per tahun. Besar kemungkinan pada the newest version we will put about between 200 and 225 kWh per square meters. That's one thing. Yang kedua, policy, kebijakan. If we policy, then kita harus connected dengan the government sebagai pembuat kebijakan, sebagai regulators. So kita banyak involved di dalam government program. Sebagai contoh adalah pada saat Kementerian Energi menyusun permen tentang ESCO, Energy Saving Company, kita ikut involved di dalamnya. Kemudian pada saat Kementerian Energi menyusun SNI, Standar Nasional Indonesia untuk chiller efisiensi, termasuk MAPS, Minimum Energy Performance Standard, kita ikut, ini masih dalam proses. Kalau yang tadi Permen ESCO sudah terbit nomor 18 tahun 2016, kira-kira gitu. Dan kemudian kita juga involved di dalam penyusunan technical guidance, energy efficiency technical guidance for OJK, Financial Authority Body, yang akan dipakai sebagai reference bagi banking untuk menilai sebuah permintaan loan, apakah ini bankable atau enggak. Jadi itu sudah ada guidance-nya, ini sudah dalam tahap finalisasi. Jadi strateginya tadi sudah disampaikan, policy-nya kita get involved dengan pemerintah dalam menyusun regulasi. That's it. Thank you.
Thank you very much, Rana. And now, okay, that we know the strategy, the policy, I'm interested to understand how it actually happens in the field with Sugwan. Sugwan, so on the buildings that you are designing and operating, actually, what are the big trends which are influencing you and your company? We talked about IoT. We talked about green energy sources. We talked also about any other things that can happen. So what are the mega trends that you are influencing?
Like Pak Agus, this is very difficult to answer because if we're talking about the trends, I think we are talking about green building in the last 5 to 10 years, yeah. But we are we're talking more about the concept, but the implementation is, I think, is still far away from widely implemented in the field. As a developer, we are very concerned to ROI, yeah, let me explain a bit. Usually in the developers, big developers like us, the development team and the operation team is a different department, and both departments have different interests. The development team usually interest on how to build the building as efficient, as cheap as possible, so can get the return on investment as high as possible. If you are talking about like 75% energy is spent on the 20 or 50 years of the operation, they don't care about that. They only care on how much they spend now and let the operation team think later. That's what the reality are. So if that happen, if we're talking green building of more efficient building, of course you need more expensive equipment to implement that. And with the what's called intention to cut the cost, usually this kind of thing is already cut in the first place before even the building is built. In the design process, usually is already cut. So that's the reality. But now, of course, there's a progress. Yeah, we are starting to implement the more efficient building design not because of it's also because of the economic reason. Yeah, first is because of the customer demand there, especially for shopping office building. Yeah, we have now the anchor, the international tenants, which quote unquote they asking a green certification. It's so if we build like a A-class shopping office building, we have no choice. If we want to market the space to them, we have to follow Pak Rana certification. Otherwise, they don't want to come. Yeah. So it's good for actually for a push for us to build a more efficient building. Secondly, I think this is the biggest reason. Is the operational cost in the last 10 years is not only double, triple, four times than 10 years ago. If you're talking about electricity in the last 10 years for commercial building, I think is triple than 10 years ago. 10 years ago per kilowatt hour like 400 something rupiah. Now the average is 1,200 rupiah, so almost 3 times. And for like a manpower, also a big portion in the operating shopping centers. Probably if we're talking 10 years ago, 15 years ago, like in Jakarta is about 2 million, now is 4 million. So it's double. And our ability to increase the what's called EPL, the service charge to tenant is not as strong as before. So we have no choice that if we want to build a building and we want to run it, we have to build efficient one. So we can reduce the operating cost as low as possible. Yeah, of course, we still have to maintain the initial cost to build, otherwise we cannot build the building. But the consideration is already there. So we need to make as efficient as possible, which still reasonable for us to build, to operate for the sake of we can operate it for our tenants. I think that's what happened now as developers.
Okay. Thank you, Sugwan. And so you talk about the people who build the building, the people who operate the building. Now there are people who occupy the building. So Edgar, for the tenants and the people who are in the building, I mean, what is the evolution of the expectations of these people when they enter in a efficient, cool building? What do they expect?
Okay, so I have to put myself as a tenant or occupants in the building so that we can have the real effect and scenarios of what we are talking about, the expectations of occupants and tenants in the building. First is tenants have different views and perspective of what the building that they are occupying actually. Beforehand, the occupants and the tenants must know what building that they are occupying today, because there are different types and classifications of buildings. Like, for example, the building is classified as C type, B, A, premium type of buildings. So it has a different views and perspective from the tenant that where they are occupying right now. However, across all these types of buildings that we have, or these occupants are staying or occupying, we have one common interest. As we said today in our development, every occupants and every tenants would like to see about the comfort space. So what do we mean by comfort space? A space is not just only within the four corners of the room where they have occupied. It's not just like a box that the occupants and the tenants are inside. These are the basic, we call it non-dynamic elements on the design. However, adding into a comfort safe to make the tenants and the occupants feel better in their working space, we have to include the various selection of components. Number one is the lighting illuminations. Whether we like it or not, it is part of the building system. The second one is about ventilation. Third one is about air conditioning. The fourth one is regarding about indoor air quality. The fifth one is about virtual and actual security. And the last one is we have about safe and sanitation. All these elements are being considered and tie up together so that we can have integrated, dynamic, functional works of the system. These are all the elements that the expectations of tenants or occupants that we would like to feel, regardless of what type classifications of buildings that they are in. Because we are talking about the well-being, the comfort, the safe, the security of every tenant that we have in our building. Because tenant is our customers and we have to take care of them. This is where we have the premium of service from deliverables of design, expectations, and the cost that our tenants are being charged for. Having said on all these things, these elements, this where we all boils down into how we are going to have an impact in terms of cost, in terms of time, in terms of protections of the brand names. Because brand names of the building is also very important to us. If we carry the brand name of the project, not only we are protecting about the occupants, we are protecting also our brand names because this is where we are advertising our own products. And all our commitments based on our mission and vision of the company are being tied up to this one to be delivered because this is where our commitment is. Our integrity for delivering the products and services to our customer is the most important thing. This is where the expectations of our customers and tenants in our projects.
Thank you very much, Edgar. And I guess in your first answer to the question, you said, okay, the question is easy. The answer is not that easy, but what is most critical is actually not to define what efficient building is, but it's really the implementation of the building. So with regards to implementation, given your experience, which one is the example that you would like to share with us that is the most efficient cool building that you have seen? And how was it different from the other buildings?
Okay, let me answer in Bahasa because my English is not so good. Yeah. Well, actually we have a design last time starting from 2008. Yeah. What we call is integrated facility building management system in Grand Indonesia projects. Yeah. That one will try to integrate all the MAP installation with the facility management software. Yeah. Recently, we also have another project which also implemented APFMS, which is actually presented by Pak Ari before our session. He also implemented the APFMS for this building, for the office building in HSBD Lot 10. But since the digital technology is very fast advanced, then between the two systems, it's quite different. Now it's much easier to implement the integration. Last time it's quite difficult to get the integrator. Yeah. In our opinion, if we have the tools to make the control and automation very fast, it also have some benefit on the energy efficient. At this moment, so far as I understand from the Grand Indonesia, they also still using this one, but because of the this one is the technology is they have a difficulty to expand the system. Yeah. But according to me, actually, with this tool, we can utilize this tool for saving energy. Because if you have a fast response from the sensors and then fast action from the actuator, then the energy is depending on the time, right? If your response is too long, then it takes times to saving the energy. That's what I have an experience on that.
Okay, thank you very much, I guess. Rana, question for you is how you plan to encourage the new and the existing buildings that are investing, to be more energy efficient?
Okay. If you're asking me about how to encourage...
And you can answer in Bahasa, I have no
okay,
problem.
Okay. Okay, thank you. But what I'm trying to say is, if you're asking how to encourage for energy efficiency on a new and existing building, then we have to identify first about the barrier that we do have. Yeah, so makes that the energy efficiency program is not so successful. So what is the step to encourage that? Let me talk in Bahasa right now. Okay, jadi kita harus melist dulu apa barrier di dalam energy efficiency implementation on the building industry. Saya melihat ada beberapa. Yang pertama adalah first cost concern, sudah disampaikan oleh Pak Sugwan. Yang kedua adalah mengenai masalah yang saya sebut sebagai stick and carrot issue. Ya. Nomor 3 adalah masalah knowledge, dan nanti ada beberapa contoh. Yang pertama mengenai first cost. Kita semua tahu, bahkan Pak Sugwan dari sisi building owner, Pak Sugwan sudah mengatakan bahwa kita lebih concern mengenai first cost. Di dalam literatur, dalam publikasi kita tahu bahwa 79% dari life cycle cost bangunan let's say the lifetime bangunan 50 tahun. Cost yang keluar dalam 50 tahun, including first cost, investment, consultant, construction, dan sebagainya, itu hanya 21%. Tapi 79%-nya adalah untuk operation maintenance. So if we talk about this, then we have to be concerned about the cost and benefit, and what we call about the LCCA, life cycle cost analysis. I think this is the problem because most of us is not concerned, even not understand quite well about the LCCA, life cycle cost analysis. Kalau kita lihat life cycle, berapa first cost untuk membuat sebuah bangunan menjadi green building? Sebagai contoh, di gedung PU yang sudah platinum level, additional investment-nya adalah 11,2%. Berbeda dengan di Amerika. Amerika kalau di platinum level, the additional cost is about 7 until 8%. But 11%, if we talk about the LCCA and with a very simple financial payback period, it just take about 3 years, 3 until 4 years. So that's the first barrier. We have to understand about the LCCA. That's why on the training on the Green Building Council, we have one session, especially we talk about the LCCA. That's one thing. Number 2 is about the stick and carrot. Kita di Indonesia ini kalau peraturan udah luar biasa, banyak semuanya. Regulation itu banyak, paling jagonya membuat. Ya, dan regulation pasti bersifat mandatory, keharusan. Stick aja yang dikasih. Carrotnya mana Pak? Saya sering nanya ke sana. Nggak ada tuh. Dalam bentuk insentif, dalam bentuk soft loan, dalam bentuk financial support. I think this is what we do need to boost the energy efficiency activity. We have to have the carrot. And the government is the one who can provide the carrot for us. Jadi salah satu contoh misalnya kemarin kami ada diskusi dengan OJK. Saya bilang sama direktur bla bla bla, nanti nggak enak sebut namanya. Saya bilang OJK mengeluarkan regulasi untuk perbankan. 20% dari portfolio perbankan should goes to the SME. Small and medium enterprise. Why don't you make another regulation as a banking day regulation that another percentage of the portfolio should goes to the energy efficiency? Because it is very important for the nation and for our next generation. Dia bilang, okay, that's a good idea. Nanti kita coba. That's one of the sample about the first cost and about the stick and carrot. Number 3 mengenai knowledge. Saya mohon maaf kepada teman-teman building engineers, tetapi saya kira saya banyak menemui kasus di mana teman-teman itu tidak semua. Kalau Sinarmas ini udah jago-jago engineer-nya. Buktinya kenapa? Sinarmas itu setiap tahun selalu menjadi first winner daripada Asian Energy Award. Tepuk tangan dong buat Sinarmas, Bapak Ibu. Oke. Salah satu contoh misalnya dalam chiller plant ada 3 chiller, 1 stop, ya, bukan karena standby, tidak in operation. Apa yang dilakukan? Mereka tidak menutup valve-nya. That is wrong. Ini salah. Anda membuang energi, itu contoh yang paling gampang. Banyak contoh yang lain. Jadi apa yang harus kita lakukan adalah harus capacity building buat teman-teman dari engineers. Dan kami juga sudah diskusi dengan BOMA, dengan BEA, dengan Asati untuk membuat sebuah kalau bisa ada sebuah capacity building yang terkait, dan saya kira BOMA sama BEA sudah bagus sekali karena sekarang sudah mengeluarkan sebuah sertifikasi. Green Building Council juga di dalam masalah capacity building itu juga bekerja sama dengan IFC, Affiliates Organization dari World Bank. IFC itu mendevelop sebuah software yang namanya Edge, the same Edge, the same EDGE, but the software name Edge. Edge adalah sebuah software untuk building simulation, building energy simulation, very simple, user friendly. Masukkan model building hanya panjang kali lebar, jumlah floors berapa, floor to floor berapa, lokasi di mana, orientasi di mana, that's it. And then halaman keduanya ada beberapa measures yang bisa dipilih ya untuk energi efisiensi. Contoh, window to wall ratio kita bisa pilih, dikecilin atau dibesarin, tentu harus dikecilin untuk energi efisiensinya. Kemudian low E kita pakai efficient glass, tinggal dipilih, kemudian kita pakai shading atau enggak, kemudian pakai LED lamp, pakai sensor, pakai variable speed, itu banyak pilihan, kita hanya tinggal klik. Cuman diklik, begitu diklik, maka energy consumption di sana ada 2 bar, satu baseline, yang kedua bar pada saat klik dia akan turun, sekian persen saving. Klik lagi, turun lagi, klik lagi, turun lagi. Very simple, user friendly. Dan ini kita pakai adalah untuk sebuah pembelajaran karena very simple ways to understand about how to do the energy efficiency. It is a free software, ya. www.ifc.org/h itu paling gampang. Saya ingin sedikit sharing tentang tadi Pak Agus sudah memberikan contoh implementasi adalah apa yang dilakukan di salah satu gedung yang dikelola. Jadi testing commissioning, Pak. It is very important. And buat kita testing commissioning sesuatu yang tidak pernah menjadi suatu keharusan. Dan saya sudah bicara sama rekan-rekan di Kementerian Industri, tolong testing commissioning itu menjadi rekomendasi, kalau perlu dibuat sebuah rekomendasi, kalau bisa peraturan. Kenapa? Contoh di salah satu proyek yang dilakukan testing commissioning, pompanya itu terpasang pompa chip water 55 kW, karena headnya sekian. Begitu diukur flow-nya, itu hampir double. Make sense, karena saya kira bukan salah engineer dalam menghitung head terlalu besar, karena itu kita harus siap-siap dan sebagainya. Kenyataannya actualnya head lebih rendah sehingga flow-nya naik. Nah kemudian kita adjust supaya flow-nya tepat. Waktu flow-nya udah persis sesuai dengan design flow, saya ukur kilowattnya. Bapak Ibu tahu berapa? Dari 55 kilowatt yang terpasang ya. 31 kilowatt. How many percent reduce? From the pumps. Chill water pump, from the condenser water pump, from the cooling tower, from everything, the building owners never realized that they pay energy bill higher than it should be. They said, I have a great building because it's very comfortable, the occupants are happy, the tenants will pay the bill, monthly bill because they are happy, but they never know that they pay the energy bill higher than it should be. So by testing commissioning, we have potential about at least 15% saving. Very simple. Yang kedua, beberapa yang low cost yang sering saya suka sharing. Misalnya, ini termasuk dingin ini. This is too cold. If you increase 1 degree Celsius, room temperature, you have a potential save about 7%. But of course, as you said, that always contradicted between the commercial guys and the operation. The commercial saying, I cannot sell the space if you put 25 degrees centigrade. Betul ya Pak Edgar? But that is okay, so that's one thing. Apa yang kami lakukan di gedung itu, kita naikkan 23, nggak ada komplain, 24 mulai ada komplain, nah kita datengin, kita ceritakan apa benefitnya. Berikutnya kita juga bisa lakukan menaikkan chilled water setting temperature. Konsultan bilang 6,7, naikkan 7. Tunggu seminggu, ada komplain nggak? Nggak ada. Naikin lagi 7,2, naikkan lagi 7,5, nggak ada komplain, terus naikin. Sampai 8, mulai ada komplain, ya kita turunin jadi 7,5. Setiap derajat kenaikan temperatur, we can save 2%. It is very simple, no cost, low cost. So that is what we do. And then from there, this building can save about another 16% saving without any cost. 16%. And then what we did also in Ngurah Rai International Airport, without any cost, we can save about a 14.5% by these measures. So we can say, sebetulnya kita bisa bilang bahwa in your building, you have a hidden treasury, harta karun yang terpendam. How to get that? Find it and fix it. I think I can guarantee on your hand, you have a 7 until 10% saving without any investment. That is what we have to learn. And how to do that, let's we learn together. I learned a lot from Pak Edgar. Thank you very much.
Thank you.
No, you have that one.
So now let's look into the future. Suguan, how do you foresee, the market evolving with regards to the efficient buildings? What are the big trends? Which segments do you think are going to be the ones investing the most into the efficient buildings?
Okay. I want to comment a bit about Pak Rana said before that to build energy efficient building, the platinum level, the PU increase need the investment in additional is 11%. Yeah. For us, 11% increase in building cost. The building is can be deciding whether you build or you are not to build. Because
different angle. Different angle.
Probably PU is different because it's government. They have a lot of money. But us, if we have to increase 11%, sometimes it will be catastrophic because it's sometimes your ROI is not reach the target you want to achieve. Yeah. You asking about what happened in the future. I think in the future the cost will be increased. The trend is always there. Like the energy cost, especially electricity, I think in the future will be increased, especially for commercial building, because politically government is too afraid to increase the residential electricity price, which comprise like 80% of the energy electricity usage, and economically probably they don't want to increase the industrial energy price. So the only field which they have a less political risk is to increase the commercial energy price. So I think in the future we have no choice to accept that fact. Also the manpower cost. This year probably 5%, but we experience like 10%, 14% in some city, sometimes 20%. It will kill us somehow. And because Pak Rana is so diligent to promote green building, I'm not surprised that in the future the government will issue the regulation that enforce us to enforce us to implement more energy efficient building regardless the cost. So I think the trend will be there. We want or we don't want, we will go to that direction. I think the first field who will follow, like I said before, is office, because we are forced by the tenant, especially grade A office, which the tenant will demand more and more, and they are very sophisticated. They have the consultant who help them to calculate the cost, the etc. etc. And second, I think the other field is the property which it's a lease property which we are not sell, like shopping centers, hotels. So because we build the building, then we manage them. So somehow we will calculate the 79% of the cost. So I think we will invest more on that one. The last one probably I think is residential property, because residential property is mostly we sell. So for us, I think our intention is to build as efficient as possible, then we sell as high as possible. And also, if we're talking about efficient cooling system, probably we cannot use the split system or a single unit system, multi-split, VAV, you have to go to a centrifugal system, the centralized one. That's the most efficient one with the water cool system. That's the most efficient one. But we cannot do that because it's very difficult for us to split the cost. Yeah, the only way to split the cost is through the service charge. And increasing the service charge is very difficult. Yeah, so it's easier for us. It's happened to also to the strata title office, which usually use VAV system. So it's easier for us just to give the single unit system, VAV, split or whatever, and then let them run the AC by themselves. Then we manage them and charge them the bill. It will be very difficult. So I think the trend will be there, that we will more efficient day by day. I do no doubt about that. But probably in the first is office, then the lease, then I think the last one is residential. Thank you.
Okay. So we are running a bit out of time. So one last question, Edgar, and if you may have a short answer that will help the organization committee. So last question is with regards to your expectations. How can the manufacturers or the vendors help you get your buildings more efficient? What are your expectations from them?
Before going to that question, let me touch base first on the principle of mindset. Why, if you are going to have an efficient building, a smart building, it would be expensive. This is the common understanding that we have today. For me, first thing first is I would like to identify what is the biggest cost on the project. There are components or elements on the project. In putting up a project, you have the civil and structural costs. You have architectural and finishes costs. You have the MEP cost. What is the percentage of the building cost for the MEP? Do you know? Okay. Well, if you are going to ask me, this is, just correct me if I'm wrong, it's a very simplistic calculations actually. The highest cost is structural and civil works, which comprises around maybe 40% of the total project cost. Yeah, this is roughly, yeah. It depends actually on how complicated is your design in your building. Because the more complicated your building design, it is more complicated for your structural component. That will make also another cost impact higher on your project total cost. However, regardless of that, the next second highest cost is the finishes, the architectural, which is more or less 30% or 35%. Say 30%, so the total now is 70%. What is the cost for the MEP? 20%? Maybe. Again, it depends. So the remaining, between 70 plus 20, it's 90. So where is the 10? Okay, so this is, the 10 is more or less, this is where we call it the reservation cost of the project. We call it the emergency cost that will happen, the variations, yeah, the additional cost that we are going to reserve in the project. But again, going back into the 20% of MEP, wherein we have the equipment, efficient equipment, we have the technology, we have the infrastructures, the IT, and all these things. If you're going to sum up them all, we are only 20%. So how much is the total cost incremental only for the MEP? Not for the entire project that we are going to calculate. This is another avenue of knowing where is the cost that trigger into the total project cost, which contributes into a smart, efficient building. Okay, so that's for information, yeah? So that we can understand where we are coming from. Because this is where we are going to put into our management so that we break down what are the costs that we are going to incur into designing a smart building. But again, whether we like it or not, today, tomorrow, and beyond, we are already in the digital world, whether we like it or not. So we have to go on with this one. This is where I'm talking about aligning now into the manufacturers, providers, suppliers in the market. There are so many, yeah? Not only Schneider. There are so many in the market right now. There are so many players. But what they are talking about into a smart building, efficient, cold building, sustainable building. There are lots of technology that are available right now in the market. Even to the single landed houses, yeah? To roco-rocos, to apartments, high-rise condominiums, hotel, malls, mixed-use development. There's lots of things. But one thing that will entice or increase or benefits the energy savings that we are going to have in our projects, irregardless whether that is a new project or that is an old project. There is no excuse for us to leave behind. We have to go on, okay? Now, when it comes to the new project, we know it already from the concept by itself. From the concept itself, we know what classifications of projects that we want to be. Because from the beginning, if you don't know what is your concept, then you don't know actually where you are going to end up. And it will be wasting time and wasting money, and sometimes it will go into inconvenience with our designers, consultants, because people are get involved on a day-to-day revisions, modifications, another concept, another options, and all these things. So this is what happened right now on the business of the real estate. Now, going back into from the concept point of view, we know it already that we have the components. We have the building system, and we have the subsystem, which I have elaborated a while ago in my previous introduction. Now, the most important on the supply, in the manufacturers, vendors, and suppliers, we're talking about in the building, there are 4 keywords. Number 1 is reliability. Why we're talking about reliability? Because it's the product that we have to put in the building. Will it stay there? Okay? Will it works there? The second thing is responsiveness. Is the product can respond to our needs as per our required design parameter? Is the product can respond to the needs adjustment of the tenants or occupants? Number 3, comfort, which I have mentioned. Does the product provide a comfort? Number 4 is about safe. Is the product safe enough? All of this one will boil down into the building life cycle effect. But what I'm trying to connect with this one here right now is that on a digital world, which we are today, and we have a buzzword of IoT, which is Internet of Things, it's already happening. So we are talking about in our building, machine connectivity to machine. Machine connectivity to people. People connectivity to technology. Technology connectivity to energy green grid. Energy green connectivity to bottom line, because this is where your cost to operate. With all saying this, what is the most bottom line? This will contribute to global environmental effect, where we are talking about carbon footprints. All along the way, this will be an impact to the generator. If you're talking about the generator, this is the power plant generator. If you consume and save electricity less on the load side, the generator will produce accordingly. Not that the generator will produce abundantly and there is a low demand. The law of supply and demand should prevail in all these things so that we have an equilibrium and balance in all aspects of producing and consuming electricity. Thank you very much.
Thank you very much, Edgar. And so we are coming to the end of this panel. I could feel a lot of passion in all your answers, and I really want to warmly thank you very much for your participation, for being here with us. And I think they deserve a very big round of applause. Thank you very much.
Thank you, Jimmy. Thank you very
Pleasure.
much. Yeah. I've been honored to be here.
Thank you very much. Big pleasure.
Alright, thank you very much. Terima kasih sekali lagi. Dan before we finish off this panel discussion, we'd like to end it by handing out a little token of appreciation to our panelists. So I would like to ask the honors from Mr. Jean, probably to hand out a little thank you from Schneider Electric. Diserahkan kepada para pembicara kita hari ini. And probably a little picture together. Jadi baru saja kita ikuti panel discussion kita, yaitu berbicara mengenai efficient building for cooler planet. Thank you very much. Selanjutnya yang diserahkan pula, dan pada kesempatan kali ini sekali lagi para panelis kita yang sudah berbicara untuk efficient building for cooler planet, Mr. Edgar Alcazar, Chief Tech Advisor Sinar Maslan, Bapak Agus, selaku konsultan, Bapak Insinyur Rana Yusuf Nasir, Co-founder Green Building Council Indonesia, Bapak Sukwantono Tanto, Director PT Ciputra Property Tbk. And now a picture together.